This is Brian Putt. Today I'd like to talk to you about simplifying value of information to the bare bones. Oftentimes, value of information is not well understood, and I want to bring it down to as simple as possible. We're going to do that by looking at choosing between two envelopes. You have a choice between two envelopes. One has $20 in it, and the other has nothing. And so, which one do you choose? Now, if you're given an opportunity to buy information about which one had the $20, how much would you pay for that information? So what is the value of the proposition without information? That's the basic. We need to understand that to start with. Well, there's a 50% chance that $20 is in one envelope or the other. So the value is $10. 50% times 0 and 50% times $20. Well, that was pretty easy, but the harder part might be, what is it worth to buy information? Well, with perfect information, on the value of the proposition is 100% times 20 minus 0, or $20. But what does that say about the value of the information? Is the value $20 if there is no cost for the information? So the value of information is defined as the value with information less the value without information, okay? And we also need to subtract the cost of the information. So in our case, the value of information is $20 minus 10, which is our reference case, that is the value with no information, gives us $10. If we pay nothing for the information. But what if we paid $11 for the information? Then the value of information is 20 minus 10 minus 11 is a minus 1. So what do? Do we buy information or not? Buying information for $11, we end up with a net of 9 in our pocket. This is for certain. That sounds pretty good. The alternative is to take our chance by picking an envelope and either ending up with $20 or nothing. Our expected value is 10. Which is better than the 9. But we have the uncertainty. What we do depends upon our risk preferences. But let's change it a little bit. What if I could play this game 100 times? Buying information for $11 each time we would end up with $900 in our pocket. That's reflected by this solid orange line over here. However, if we selected the envelope each time, what do we expect? Well, the expectation is $1,000, but is uncertain. It could be as high as $2,000, but that's really not very likely. The more important concept here is that picking the envelope every time, we would have an 86% chance of being better than the $900 with perfect information. So here's the distribution of 100 trials, 100 chances of picking the envelope. And we can see that it has an expected value of 1,000, which is what we said. But you'll notice that there's an 86% chance of being better than the 900. And only a 14% chance of being less than the 900. So what if we paid $9 for the information? Well, now the no information case hasn't changed, but my perfect information has moved up to 11. And so now I have an 82% chance of being better than picking an envelope at random. 82% better. Or said another way, there's only an 18% chance of being better off by picking the envelopes and not getting the information. And of course, if we paid $10, that's the value of the information at no cost, then we'd be indifferent from an EV perspective, but might have a preference based on our risk preferences. When quoting the value of information from a study, always include the cost of the information. So that might be conducting a pilot, doing a market survey, any other type of cost that you might incur in gathering that information. You may find this video useful in teaching others about the value of information. If you want to learn about more complex value of information analyses, please see my videos on my YouTube channel. Thank you for watching.